Okay, next one. Now next one, you may have, maybe you have not come across this thing, so I tell you about this thing first.
Okay.
Right. Now, this is about centripetal force. Centripetal force is about circular motion. So
Okay.
when an object move in a circle, when an object move in a circle, there must be a force pushing the object towards the center of the circle.
Mm-hmm.
One more time. When an object move in a circle, there must be a force pushing the object towards the center of the circle. Otherwise, they cannot move in the circle. So the first example here is an object attached to a string or a rope, right? And we try to swing it in a horizontal circle. We try to swing it in a horizontal circle, right? And in order for this pail or this object to move in a circle, something must be pulling the object towards the center. There must be a force towards the center. So what is this force that is pulling this bucket or this pail towards the center? It is the tension in the string. The string is actually pulling it to the center. So the string is providing the centripetal force. So there is a centripetal force. Now this force, according to this Newton's law of motion, this force is related to the acceleration. So if there is a force towards the center, there must be an acceleration towards the center also. So things that is moving in the circle. Okay.
Okay.
The next case, let's say if there's a car, okay, the car is negotiating a corner, turn like that,
Mm-hmm.
and the car is moving in the circle, or maybe it's part of an arc, part of an arc. So in order for the car to move like that, to turn in a circle, there must be a force pushing the car towards the center. Otherwise, the car will go straight, right? Or not? And the car will
Mm-hmm.
go straight. But you want to turn, there must be a force pushing it towards the center. And that force is the centripetal force. This centripetal force cannot be provided by the engine of the car, because the engine of the car is only pushing the car forward. So when you turn, something has to push, and that force is the frictional force on the tire. That's why when you see this racing track, usually when the place where they turn the corner, you can see a lot of marks there, the tire mark at the corner there, because the friction is pushing the car towards the center. So you can see the rubbing of the tire against the road. Okay, so the friction is providing the centripetal force. And this centripetal force produce an acceleration. And that acceleration, this one is the second case, and that the acceleration depends on the radius, how big or how small the turn you are turning, and also the velocity of the object during that time. So it depends on two factors. And how exactly they are related? The acceleration for this object that's moving in a circle is v squared over r. That means it is the velocity square divided by the radius.
Mm-hmm.
Now, assuming that you don't know this formula, don't know, I have not learned before, I don't know the relationship is a v squared over r, not learned before. But I know there's a relationship between the acceleration, velocity, and the radius. That's all I know. That I know that there are three factors, and these factors, they are related. In what way they are related, we don't know. We have not studied before. Okay, not you know the situation. So don't worry. Dimension, we check the dimension, and the dimension will provide us with the answer. The dimension will tell us exactly how these three factors, they are related to one another. Okay, no? Any question?
No.
No. That means assume that we don't know anything, Assume
Mm-hmm.
that we don't know anything. Okay? Assuming that we don't know the relationship, we don't know the formula. We only know the relationship is acceleration here, over here. Acceleration is the velocity
Velocity.
and the radius. How they are related, I don't know. So I say acceleration equals to v. It can be v square, v cube, or v alone, don't know. So I said v to the
Mm-hmm.
power of m lah. Then how is it related? The r, how is it related? I don't know. It can be r to the power of 1, r to the power 2, r to the power
Okay.
-1, r to the power -2. I don't know the exact relationship. So I say r to the power of n.
And
So don't know the relationship, we just call it m and n, right? The
okay.
power is m and n. Okay. Now acceleration, what is the dimension? Just now we have found earlier, we have learned earlier,
L over T square.
L over t squared. That's right. Now what is the dimension for velocity?
L over T.
L over t. And this L over t, we don't know how is it appear, so we put the m there to the
M.
power of m. Okay, not because we don't know if it's v square or v cube, we don't know, so we put m there. Now what is the dimension for r, the radius, which is the length?
The line L.
L, correct. And how does this L occur inside the equation? Don't know, so we say L to the power of n.
And
Is that okay?
yeah.
Okay, so now I expand this term L t to the power of -2 over t square is t to the power -2. Have you learned this before? Divide by t square means t to the power -2.
I don't think I did. No.
Huh?
I don't.
No,
I don't
no.
think I did.
Okay,
No, I
never
don't
mind.
think so.
Uh, this is about indices, right?
Mm-hmm.
Let's say if you have something divide by something and it appear below there, there's a line, it appear at the denominator there, and you want to
Mm-hmm.
move it to the top, you just add a negative sign there.
Okay.
Okay, so you
Mm-hmm.
just add the negative sign here. Okay, now it's L over T. So this is L to the power of m, L to the power m, then T to the power of m. The power, you just give them T to the power m. And since the T to the power of m is at the bottom, so you have T to the power of negative m, negative m. Okay. Then the L, which come from the R, the L to the power n, we put down the L to the power n. Okay. Now it's time to group all the terms which is alike, group them together. So example here, L to the power m and L to the power of n. So when you multiply these two together, it becomes L to the power of m plus n.
Okay.
Then this one is t to the power of negative m.
M.
Okay. So we allow them to mix up in terms of m and n. Then I try to compare the left hand side with the right hand side. So the L here has the power of 1. The L here has the power of m plus n. The T here has power of -2. The m here has the power, the T here has the power of negative m. Okay, so I say that this negative m is the same as this -2 because they come from the same formula. They have the equal sign there.
Okay.
Their dimension must be the same. Their
Same.
dimension must be the same. So I say that this negative m is -2. Negative m equals to -2 means what?
Two.
M
M
equals
equals
to
2.
2. Then over here, I compare the L with the L, right? I compare the L with the L, and I say that m plus n equals to 1. The m plus n here, which is orange color, equals to the 1 here, which is also orange
Mm-hmm.
color. Okay, so I form this equation. Then, oh, what is m earlier on? We have found out earlier on
M
m
is 2.
is 2. So the 2 you bring over to the other side. 1 minus 2 is negative
Negative
1.
1.
Negative 1. So now can you put back all these numbers, the m and n, back into this original equation here?
Can.
Okay. So we say that, oh, a is actually
V over
v to the power
square.
of m. M is
2.
2, correct. Then r to the power of n. N is what?
Negative 1.
Negative 1. So we just put it down. The next step we just put down. Oh, we know the formula for acceleration is actually v squared over r. So
Over R.
which is this one, right?
Okay.
V squared over r. So the one of the use of this dimension is to find the exact relationship between the quantities. Okay. Of course, we must know that this equation involves these quantities. Okay, but we don't know exactly how they are related, and we can put the m and n there. If we find out the m and n, then we know how they are related. Any question?
No.